In this section, we're going to be talking about proportions, and let's take it back to something that we've already done. Remember whenever we talked about equivalent fractions and we found equivalent fractions? These were things like if we had 3/5 equals something over 20. This was where we were creating a new denominator, an entirely new fraction, but it had the exact same meaning as the 3/5. So if you'll remember, whenever we did this, we said, okay, what do we have to multiply to 5 to get 20? And that would have been a 4. Well, then we did the exact same thing to the top, so that we were technically only multiplying by a 1, not changing anything, just manipulating it around a bit. So 3 times 4 is 12. That's the same thing as saying that 3/5 is the exact same as 12 over 20. If I were to, have a pizza or something and cut it into 5 slices, then if I were to shade 3 of those 5 slices, it would be the exact same amount as if I had cut it into 20 pieces and shaded 12 of those. Visually it would be the exact same amount. Okay, we found that missing number here because since we're dealing with equality, we knew that these fractions had to be the exact same thing. This is the idea of proportions. Whenever we talk about two fractions being equal to each other, we're saying that the numerators and denominators are in the exact same proportion. A proportion, technically, the definition for it says that this is where we are talking about two ratios or rates being equivalent. Equivalent is the very big important word there. When we deal with proportions, there is always an equals in there because we're saying that these things are the same. Now, when we read proportions, if let's say we have something that looks like this, $20 over 4 hours is equal to $40 over 8 hours. We're saying that those two things are equivalent, and hopefully we can see that they are, because if I were to multiply the 4 hours times 2, that would be 8 hours, and if I did the exact same thing to the top, $20 times 2 would be $40. So we're saying that as the hours double, the money doubles also. That's what that's talking about. Now, when we read proportions, we read it in this manner. This proportion up here reads as $20 is to 4 hours as $40 is to 8 hours. So the equals here is represented by the word as. Okay, let's write a couple of these and see how they work out. This says write each proportion. $9 is to 12 cans as $18 is to 24 cans. So if I were going to write that as a proportion, I would want to write out, first of all, $9 is to 12 cans as is our equals. $18 is to 24 cans. Now we have kept that in the same proportion, and hopefully we can see that those are equivalent. If I were to multiply 12 times 2, I would get 24, and multiplying the numerator by the same amount, $9 times 2 would be 18. So these are equivalent fractions, basically. Okay, the next one here says 28 people is to 7 cars as 16 people is to 4 cars. Well, if I want to write that as a proportion, I would want to write it exactly as it says. 28 people compared to, or is to, 7 cars, as is our equals, 16 people compared to, or is to, 4 cars. So this is what the proportion would look like, and those things now are in that same, they're equivalent fractions, they are equal.